Um, but the big idea with SketchUp was for me to introduce something else to you. Now, SketchUp hasn't been around forever. When I was coming out of college, there was a new program called CAD, C-A-D. Have you guys ever heard of CAD before? And CAD is a two-dimensional drawing tool. SketchUp is, of course, three-dimensional drawing tool. But CAD was, a relatively new thing. Some engineer out somewhere at some university put this program together, and you use a computer to draw two-dimensional shapes. Now, most of you guys in middle school have drawn two-dimensional shapes and stuff for fun. But in this case, you use CAD for work in designing either buildings or you know in where I saw at my wife's work was they used it for designing operations for coal mines. And so anyways, the CAD was essentially just a drawing tool, and the people that learn CAD were making a lot of money because they, essentially they learned to draw on this program that can print out these large detailed schematics. And being a CAD operator was a great thing to have on a resume for a lot of people, and it made them a lot of money. And so, just like this, SketchUp it's not the new CAD because not everybody uses it, but it's something that I wanted to expose to you that you might say, hey, I enjoyed this a little bit. I can be good at SketchUp on my own time where you don't have to go to school to learn it. And I can use that as a resume piece and put that on my resume, or I could get a job designing things using SketchUp. And some of you guys are artists, some of you guys like some of these technical things. And the idea is that if you like it, you could choose right now to pursue doing more of it. So you could get a job and, just like the people that were CAD certified or CAD operators, make money with it. Okay, so that's the goal. That was my goal, was to expose you to hopefully something new. Now, some of you guys did say you've used it in the past, and that's awesome. And if that was the case, then you just got to play with it a little bit more. Okay, all right, let's talk about the test, because most of everybody got the test done. There were actually 3 standards passed. So I'm going to explain this weird chart, and I still haven't got my good mouse fixed yet because I don't know what's going on with it. But so if I bounce around, I'm sorry. This says there are 4 standards on the test. HSN 1 and 6, which is number, and then G is geometry, geometry 1, geometry 23. There were actually only 3. I realized that this was accidentally left on there. That's kind of the default. And I did not, I tried to go back and edit it and I couldn't do it. So I'm going to have to go back and edit it for next year. But this one right here is actually over here in HSG 23. So HSG 23 is kind of the big one on the test. It's find measurements among points in the coordinate plane. So it's talking about midpoint and line partitioning and distance formula, and using the complementary supplementary rules. Okay, now there's also HS.G.1, which is the first geometry standard, which is, well, definitions. We talked a lot about how important the definitions are in vocabulary. This is really just vocabulary. Okay. And so again, this one right here is actually G23. So HSG.G.1 is also going to be on the next test. It's a lot of vocabulary. Okay, and so this was kind of a test warm-up. Like, did you do a good job learning the vocabulary? And if not, you need to be good with the vocabulary for the next test, because there's a few more vocabulary words. Okay, so what do these numbers mean at the bottom? This means, like, so for example, for G23, blue is mastery, and oh, there's 2 of these rows because I had to split the class into 2 because some of our students in the class are not in the same infinite campus grouping. And so this is kind of a total. So of everybody that took the test, 4 is exceeds mastery, blue is exceeds mastery. 6 in the green are mastery, and 7 in the yellow are near mastery, and 0 people needed to remediate. So you'll see like our numbers are good for green and blue, and there's always a few kids in red for remediate. That's perfectly normal. Not everybody is going to be perfect every time, or, quote unquote perfect. And also, like, is the test valid? Is the data valid? Well, already kind of it's messed up because I forgot to include that. But this was a common assessment taken by everybody in the district for the last couple years for geometry. Now they are moving to a new summative in Mastery Connect, and it looks a little different. But this was the geometry test that everybody in the district took there for a couple years. And I have not had time to move over to their new one. So I just said, I'm going to keep it the same one. This is the test I've taught the last couple of years. So that hopefully that makes a little bit of sense. You guys can see what standards you guys were tested on. Okay. All right. Any questions about reading your scores on Mastery Connect? Do you guys like Mastery Connect? Not like Mastery Connect? Did anybody find it frustrating? Does anybody want to give me any feedback on Mastery Connect? I, as a teacher, have my own opinions, but I'm not a student. So, I mean, I definitely want to give you guys a voice. Promise not to hold it against you. These are some of the item analysis, and I actually went back and checked number 6. So normally, like, question number 6 is like, oh, I got the key wrong. But we didn't do very well on number 6. And I went back and checked it. It was a problem that you had to read, and we talked about it in class a couple times, where you solve for something, but that's not what the question's asking. So definitely a test taking strategy is to read the question really carefully. And then like 7 and 9 also would be ones where we're going to go back. Now, again, I haven't had everybody take the test yet, so I'm not going over the test questions yet. I hope to do that in a little bit. Maybe if everybody can get it in, maybe Wednesday. But overall, pretty good, really, pretty good. Okay. All right, there's one person that gave me feedback on Mastery Connect. You guys are being very quiet. Definitely take some time to put in the chat. It'll wake you up. When you take a test in the future, and I wish I would have talked about this a little bit before this test, but that's fine. Try to do as much of the test without notes or help. Now, this one's different because you had a formula sheet, and I said, just go ahead and use the formula sheet. If you want to commit the formulas to memory, then do it. But it wasn't my expectations that you guys memorize the formulas. But as far as like looking back at previous notes or previous examples, I would not do it. It's not worth it. You guys will be fine grade wise, and you're not giving yourself an honest feedback as to what what you know. And ultimately, what you guys want to do starting now, your sophomore year, is you want to try to replicate kind of the ACT conditions as much as possible. Okay, so if you have lots of notes and you're looking up past work, then you're not preparing yourself for the ACT. And when you get to the ACT, your brain is not going to be used to recalling the information. You're going to say like, well, for the last 2 years, I was looking back at my notes to find the information. So when you take tests in here, I say you can use resources from class that you've written down, because it's virtual school, and I get it. But you really want to try to do as much as you can without, because you guys are going to take this ACT, and there's a lot of scholarship money for the ACT, and there's a lot of opportunity that the ACT gives you. Okay. Or maybe you're not looking to pass the ACT so much, but you're looking to get out of high school into a different vocational trade or something. You take a test called the Coyote. And I've worked with a couple students on the Coyote, and I don't think it's as like brainy as the ACT, but there's some very brainy questions on there. Like how do I say it? The ACT is more like word based and logic based, and the Coyote is like, here's this crazy equation, you got to know how to solve it. And so, even if you're not focused on the ACT, you still want to try the test without your notes so you can maybe take the Coyote. You gotta be college or career ready, so you're gonna have to do one or the other. Okay. All right, any questions on that? Okay, and then you're really training your brain for endurance. Okay, so what else we got? Great mathematicians. I want to talk about if you just came in, please send me a message so I know you're here because I already took attendance. I want to talk about this guy, Muhammad ibn Musa al-Khwazami. And if al-Khwazami sounds kind of familiar, it should sound like algebra. Okay. And so this guy is known as the father of algebra. If you look at where he lived 780 to 850. So this was about the time of the Romans. So he was born in Persia, and while he was in Persia, the Ottoman Empire came up and they took over Persia. And so he was brought into this Ottoman fold. I don't think he grew up Muslim, but when the Ottomans take over, actually the Ottomans had a very, very liberal and open feelings about Christians and Jews living in their empire. They really left the Christians and Jews alone for the most part compared to what other civilizations did. But he most likely did become Muslim, which is indicated in his name. But he probably grew up I think it's Zoroastrian, whatever it's called. It's one of the early pagan religions that they talk about in the Bible. But he did math and astronomy and geography, and he was really smart. And he got into this thing called the House of Wisdom. So one of the great rulers recognized his talent, and he said, "You're going to join my House of Wisdom." And they sent him off to India and China, and he saw what they were doing over there. And it's really, I mean, it really, like, for the West to incorporate the ideas of someone not from the West is really amazing. So he was obviously far ahead of his time in order to make it into our academic canon. So he settled in Baghdad, which is kind of like, the center of intellectual thought at the time, like later on in Alexandria, Egypt, where the great library was, and kind of like, London during the Enlightenment. And so he wrote this book called The Compendious Book of Calculation by Completion and Balancing. If you ever remember me talking about, or a teacher talking about balancing equation, inverse operations, that's this guy. This guy came up with the rules. So every time we say, like, that's a rule in algebra, or that's not a rule in algebra, you can't do it. This guy came up with all the rules. And he literally wrote the book on algebra, which is amazing. And he also did a number of things. He solved quadratics, which we haven't solved quadratics in here. You might remember it from last year, but solving quadratics is hard. It's very different than solving linear equations. He made sine and cosine tables, which is tedious calculations, but they use it for geometry and map making and land surveying and everything else. And he really, just one more thing, just algebra was such a departure from all the math. And so, like, all the math that was in kind of the Western world was based on the Greeks and a little bit of the Egyptians, but the Greeks really focused on the geometry. They've really focused on coordinate geometry and shapes, and studying like proofs from shapes to prove math postulates and theorems. And he literally went away from that, and he said, I like everything that they did, but we're going to apply the algebra to it. So just a very influential guy. And I don't know exactly what he did to bring it in, but if you remember, like the Romans had Roman numerals and they didn't have the number zero, so there was no zero. Zero came over from India, and I want to say there's a decent chance that he might have been in that group that brought over zero, because Europe, they operated with these Roman numerals, which were just awful at doing math calculations. And this guy, like, remember, what we use now is Arabic numerals, right? These are Arabic numerals, and that's, when we went to Arabic numerals, our life got a lot better. So, all right, that's famous mathematician for the day, Muhammad ibn Musa al-Khwarizmi. Let's see. We're gonna go over geometry. Did I put that in here yet? No. All right. I'm gonna show you something else later when I put it in. But here's what we got: turn in SketchUp PBL. Hopefully you guys get that in soon. And then transversals. Wednesday there's going to be a Delta Math assignment. Okay. And then we're going to write equations, and we're going to use point slope form for that. And then there's going to be a small little formative on Friday, and then fall break, and there's no school Monday, and I'll see you guys Tuesday. I won't see you Tuesday. We'll have to figure out what the schedule is because it'll look a little different. There's a good chance we'll just meet Wednesday, and I'll have to either figure out if you guys are Algebra 2 are going to meet Friday. So, all right, so let's talk about transversals, okay? All right, so this is, all these examples are from your assignments. So if you want to write these down, you can use these. But basically you have two lines, and if you split these two lines with another line anywhere, anyhow, this line right here is called a transversal. Okay, so transversal across two lines. Now, when that happens, you have a relationship between these angles that are defined, and they're going to be more specific when those two lines are parallel. Okay, so look right here. We have parallel lines, and that's parallel line markings, right? So these two lines are parallel. And to say parallel, like if this was line R and this was line Z, you would say line R is parallel to Z. So you have these two straight lines. Whereas, if you had a perpendicular line right here with R and Z, you would say R and Z are perpendicular, or R is perpendicular to Z. Okay. So pay attention to the congruency markings, because that's very important. You can't make any assumptions. You can't say, well, it looks right. No, it has to be congruent. Okay. So what do we know about these when these are congruent? Okay. Well, if you see, this is top right, like on the right side above, and this is on the right side above, these are called corresponding angles. Okay. And these are all in your notes. Maybe we should just go to these notes. Let's see. How we get them from here? Right. Transversal lines. Okay. So you have exterior side, and then you have interior side, and that's going to be important. And then these are actually them right here. So I started talking about corresponding angles. You'll see, like, I use top right, and the corresponding angles are equal. Okay. Same. Oh, sorry. Like I said, my mouse. There's alternate interior angles. Okay, so they alternate sides of the transversal, and they're on the interior, and those are equal. I'm going to try to say the word congruent. I think congruent is a better word, but there's same side interior angles. So it's the same side, and they're all both on the interior. And you'll also see these being called consecutive angles. So these are also consecutive angles, okay? And these are supplementary, which means they add up to 180. And there's alternate exterior angles, which is alternating sides of the transversal, and they're on the exterior. And then you have same side exterior angles. So these, same side, but they're on the exterior. That's supplementary. Oops. And then corresponding angles. Okay. So here's your vocab word right here. Remember that standard vocabulary. You're going to have to use these vocab words to know how to set up your equation. And again, parallel lines, transversal line, you're going to have to know that. Okay. All right. Everybody with me? Parallel intersecting. Yeah. Okay. All right. So back here. Okay. So what do we do here? All right. Well, we're going to solve for X. So these are anybody? These are alternate exterior angles. And what do I know from alternate exterior angles? Well, I'm not going to go back to that chart, but I know they are congruent. So they're equal. So it'd be -1 plus 14x is equal to 12x plus 17. Okay, and you can solve for x and solve for the angles. Okay, and it only works if these are congruent, and we know that these two are equal because we have to know why, because they are, well, they're alternate exterior angles. You can think about it. Okay, so this let's back up here a little bit. This is an angle, and we know that this has to be the same because this line is parallel to this line, and this line is obviously the same line. So we know these two have to be the same. And then these two angles right here have to be supplementary, but that means that this is also the same as that. And then these two angles are vertical angles right here. And we know they're both the same. And then, same thing going around, it's supplementary. And so you can work out the logic where you know what's congruent and what's not, okay? So right here, what are these? So what are these? These are corresponding. So same thing. So 21x plus 5 is equal to 23x minus 5. And because corresponding is congruent, or they're equal to, okay? All right, so you just set it up and then solve for x, and I don't think I need to solve for x for you guys. Minus 21x both sides, and then that'd be 2x, and then plus 5, so it'd be 10 equals 2x. Okay, so that's what you guys are going to do. You need to identify what it is. So if you have this angle, that's alternate exterior angle, and then solve. Okay. All right, that's one assignment. And then this is from a different assignment. And now we are applying, parallel lines, transversals, et cetera, et cetera. It should mark, this worksheet's not great. It should mark these as parallel. It should. Okay, and then these should be parallel right here. So these are different. So you see how I give 1 on these horizontal and I give 2 on these vertical. So, it's the same parallel markings, but normally it should be like all marked out. And I don't think it's in there, but it says name 2 or more parallel angle segment, name 2 or more pairs of parallel segments. Okay, so I kind of did this. So NP is parallel to, remember we talked about, that's the notation, to line segment MR. So it should look like that. You should have the parallel symbol and you should have the line segment symbols like that, okay? Name 2 or more segments skew. So what's this word skew? Skew means that it's not parallel and it's not perpendicular. It's not on the same plane. So they won't touch. So what lines won't touch? Okay. Well, let's see. How about RQ is skew Can you guys think of one? So here's RQ right here. How about NP? There's a couple different choices. But do you guys see, like, as RQ goes as a line, it will not come anywhere near NP at all? That's skew. Okay. That's an important word to know. All right. Any questions on that? You guys good? Name two transversals for parallel lines in OPQ. So in OPQ, okay, these are the parallel lines. And name two transversals. Well, the transversals would be NP and OQ. Or QO if you want, right? So if these were the parallel lines right here, the transversals would cut across both lines, right? Not RQ, because RQ only cuts across the one. So transversal has to cut across both. Okay, hopefully you guys are good with that. All right. Okay, any questions? All right, so that's a different assignment. And it's going to come down here to this. Okay, oops. And let's see. Using the figure below, state the transversal that forms each pair of angles, then identify a special name for the angle pair. Okay, so first of all, let's just call it like, if you have R and T, no, I'm sorry. If you have K and L, so we're looking at this one and this one. A transversal would be like this one, right? Now, we know that 5 and 13 are corresponding. Is 5 congruent to 13? Is 5 equal to 13? Yes or no? What do you guys think? Because I know this is a transversal and I know that 5 and 13 are corresponding. Is 5 and 13 equal to each other? No, they're not. And because it's not parallel, they're not parallel. So remember, the properties are only there for parallel lines. Okay. But the names are still there. Okay. All right. So let's see. Line angles 1 and 2 for 1 and 2. The transversal is I'm gonna say it's R. Oh gosh, I didn't do this ahead of time. I mean, it should be where it's like different. Like here 2 and 10. Oh, it's 12. Oh, it's 12. That's what I was saying. Like, what the heck? 1 and 12. 1 and 12. All right. So the transversal is R. Okay, because R goes through both angles. Like it wouldn't be T. It wouldn't be M. Okay. And the special name. So 1 and 12. So 1 and 12. These are anybody? Alternate sides, exterior. So alt exterior. Now, again, you don't have to say anything right here, but these are not congruent because M and K are not parallel. Okay. All right. So one more, 2 and 10, 2 and 10. These are right here. And 2 and 10 are corresponding. And right, they're both on the top, same side. And the transversal, well, it's the same thing, it's R, because like, I left the markings right there, so I know they're there. Okay. All right, any questions about that? All right, a lot of this is just practice. Guys, train your brain. And if you just go look up the answer key right away, you're not training your brain. You guys are trying to make yourself smart so that the rest of your lives will be easy. If you're not smart, if you have not trained your brain, the rest of your life is going to be a little bit more hard. Okay. All right. So measure angle 58. This is where you want to be. This is really where you want to be. Okay. You want to be able to do this. Measure of angle 2 is 58. And measure of angle 13 is 111. 13, 111. Find the missing angle measures if X and M are parallel. So X and M are parallel. So these two are parallel. Right? So we have a transversal. And Z is parallel to Y. So Z is parallel to Y. Okay, so that means that this is a transversal and this is a transversal. Okay, all right. So let's see what we got. Well, I know, for example, that 11 is 58, right? Because it's vertical. So 11 is 58. And I know that 4 is 111. Okay, now what else? Like 111 and 3, like these two are supplementary, right? These are supplementary. So 180 minus 111 is 69. So angle 3 is 69. Okay, now let's see, can we apply one of our other theorems? Let's see. Like angle 2 and angle 8. Would you guys agree that angle 2 and angle 8 are corresponding? So, Y and Z are parallel, and there's a transversal, so 2 and 8. Now careful, because 1 and 10 and 9, like this is split, so 1 is not going to have a corresponding angle. But well, actually it'd be all of 10 plus 9. 10 plus 9 is the same as 1. So this is also 58 right here. 58. Okay, and so you see how it's going to be a lot of the same numbers? It really is. Number 6 will be like there's 180 in a triangle. That might be how you do that. So 180 minus 58 minus 69. Okay. All right. So you guys are going to try to fill that out. Okay. All right. I think that I have covered a bunch today. And looking ahead, we looked ahead at the week. Oops. And so Wednesday, we're going to talk about finding slopes and using point slope form. So definitely get here Wednesday. And if you haven't taken the test, then please take it today or let me know what's going on. Send me an email. And if you need help, please reach out. Okay. All right. Any questions, guys? Any questions at all? How you guys feeling? You guys feeling good today?